The usefulness of blockchain technology comes from its security, immutability, and transparency. All nodes, which is a technical term for all devices participating in the network, have access to the updated and verified information stored in the database simultaneously and at all times. These features enable huge potential financial and industrial applications. Both the private and public sectors can benefit from blockchain technology. The second part of the course focuses extensively on such applications and the way blockchain can transform industries and businesses around the world. Okay, we already said that recording information and organizing it in a ledger resembles an accounting system. Blockchain is like a pretty sophisticated accounting system from a technological point of view, but still an accounting system. A blockchain distributed ledger is stored and maintained by an entire computer network, rather than on a single computer, server, or piece of paper. This is a true element of innovation. If you are still not convinced by the value proposition blockchain brings, consider the fact that the accounting system as we know it today has existed since the 15th century. Yes, that's right. The double-entry accounting system was introduced by Luca Pacioli in 15th century Italy. It is based on the idea that we have two effects on each side of a transaction, a debit and a credit. This formed the basis for company balance sheets, which are the ledgers of assets and liabilities, in other words, what a company owns and what it owes. By codifying these rules, Pacioli provided much-needed order and tools to enable enterprises to scale efficiently and track and communicate all of their financial information internally and externally. Over time, the complexity of economic transactions has increased, and business enterprises and government bodies can find handy some new tools. In Pacioli's time, business audits were done regularly, on a daily basis. This is not the case anymore. It's impractical to have real-time reporting at the scale at which corporations operate nowadays, at least not in the traditional way. Such lack of accountability has resulted in a number of high-profile corporate disasters and bankruptcies. We've all heard the cases of Enron, WorldCom, and Bernie Madoff's Ponzi scheme, to name a few. Blockchain can change all this. With its transparency, security, and immutability, it can provide almost real-time audited reporting to stakeholders and regulatory bodies. Imagine how much efficiency and further progress such technology can bring to the world. Before we move on, we should mention that blockchains can be classified broadly into two main categories: public or permissionless blockchains, and private or permissioned blockchains. The distinction comes down to who owns the network infrastructure. It is similar to the distinction between the Internet and corporate intranets. The first type is a public network, which everyone with the right hardware and software can join, support, and use. This is the case with the Bitcoin blockchain, as well as most other public crypto assets. Here, the benefits of decentralization are the most prominent. The second type is owned by an organization or a consortium and is open only to its members or whoever has a permission to access it granted by a gatekeeper. This is much closer to a centralized database, despite the fact that it's still a distributed computer system. Many large financial institutions and other corporations are actively developing such private blockchains to streamline their operations and benefit from the efficiency that blockchain architecture brings about, while still maintaining the privacy required for their internal operations. Think about the current state of the banking system. At present, all banks are required to do careful due diligence on each and every one of their clients to prevent financial crime like money laundering and terrorist financing. This requirement is called Know Your Customer, or KYC for short, and takes a huge amount of time and paper processing by large teams at each bank. Each bank does KYC separately, so the process can be repeated many times over for the same clients if they have dealings with different financial institutions. Imagine how this process can be optimized if a group of banks shares a private blockchain where each client is onboarded only once, and all parties can trust the information in it. The regulators and other government authorities could also access and audit this information at any time. Another straightforward example that comes to mind is securities trading and settlement. Currently, this process involves multiple steps and intermediaries, which makes it expensive and time-consuming. When a buyer and a seller want to trade a security such as a stock, they need the involvement of a stock exchange, clearinghouse, and often broker-dealers to execute such a transaction. All the trading information must be recorded strictly and made available for regulatory audit. The necessary steps take at least 2 or 3 days until a trade is settled, meaning that the buyer has received the stock, the seller has received the money, and everything is recorded properly. All these processes can be streamlined on the blockchain, thus enabling simultaneous trade execution, clearing, and settlement in a matter of minutes. And again, regulators will be able to check the transaction records instantly at any time. These are just a couple examples demonstrating some cases of blockchain technology that can streamline the financial sector. Various implementations of blockchain technology can fit different purposes, objectives, and industries. We'll go into greater detail of such industrial applications later in this course. In our next lesson, we'll get acquainted with another of Bitcoin's 5 forces, cryptography.